Hi everybody, 11 Institute welcomes all the students of Standard 10 in part 2 of the video lecture series for science, and we have been discussing about chapter number 11, the human eye and the colorful world around us. In the previous video lecture we have studied about the structure of eye, right, the basic components which make the eye and the functions of them. And today we are going to discuss about a very much important topic, power of accommodation. Although small but very much important topic, power of accommodation. Before that, first understand the meaning of accommodation. See, human eye, suppose here I am having the eye lens, right? This single eye lens is easily able to see an object which is quite near to it. And suppose an object is over here. This eye lens is also easily able to see an object which is far from it. Right. Now this is the power of this lens, that it is able to see the near object also, it is able to see that far object also, but in order to see a near or far object, this lens has to make changes in focal length. The lens has to make changes in focal length. And this power of getting some changes in focal length is known as nothing but the accommodation. The lens is accommodating itself, or rather I can use a better word, it is adjusting itself. It is adjusting itself to see a near object or far object. That adjustment is known as accommodation. I hope that is clear to you. Fine. And ultimately, the change is in focal length of eye lens, but this change is ultimately undertaken by the ciliary muscles. The ciliary muscles, they contract and relax and ultimately increase or decrease the focal length of eye lens. Let us see now what is given in textbook about this. The ability of the eye lens to adjust its focal length is called accommodation, right? The ability to adjust what? To adjust focal length is called accommodation. The ability of eye lens to adjust its focal length is called accommodation. The eye lens can increase the focal length or it can decrease the focal length to see the near and far objects. Fine. The eye lens is composed of a fibrous jelly-like material. We already know this. Its curvature can be modified to some extent by ciliary muscles, right? Curvature means godai. The eye lens can be of this shape and it can be of this shape also. Here the curvature, here the curvature is more, here the curvature is less. But this curvature is controlled to some extent by the ciliary muscles. The change in the curvature of eye thus changes the focal length. Yes, if curvature is more, the focal length f is less. This lens is having less focal length. If curvature is less, then the focal length is more. જો આ ગોળાઈ વધારે હોય તો focal length ઓછી છે. બરાબર ને? ગોળાઈ ઓછી હોય, if curvature is less, then focal length is more. That is quite clear to us. Fine, this is the image which makes it quite clear. You can see here the curvature is less. In this image the curvature is less. I will write over here, curvature is less. And here you can see for the lens the curvature is more. Fine. Now if curvature is less, the focal length over here is more, and if curvature is more, the focal length over here is less. But what makes or what happens to do so? Right? What makes this happen? Why curvature is less and focal length is more? That role is played by the ciliary muscles. You can see the change in ciliary muscles over here. Now let us see what change does the ciliary muscles undergo. When the ciliary muscles are relaxed, the lens becomes thin. Now where do you see a thin lens? This is thick lens. This is thin lens. It means that the ciliary muscles are relaxed over here. The ciliary muscles are relaxed. When the ciliary muscles are relaxed, the curvature of the lens will be less. If curvature of the lens is less, focal length will be more. And if focal length is more, we can see far away objects. We can see the objects which are situated far away from the lens. Vice versa, totally opposite of this. When the ciliary muscles contract instead of relaxing, if the ciliary muscles contract, the curvature of the lens will be more. The curvature of lens will be more. If the curvature will be more, the focal length will be less. If focal length is less, then we are able to see the nearby objects very much clearly. Fine, so you should not forget this. This is quite explanatory, right? Let me make a summary over here. First we will erase this, and now we shall write over here. See, the story or the control is with ciliary muscles, right? Ciliary muscles can be in two states. Either they will relax or they will contract. If ciliary muscles relax, the curvature of lens is less. If they contract, the curvature of lens is more. Right? If they relax, the curvature of lens is less. If they contract, the curvature of lens is more. Now if curvature of lens is less, the focal length f will be more. And if curvature is more, then the focal length f will be less. Now if this is more, we can see far objects clearly, and if it is less, we can see the near objects clearly. I hope this summary is clear to you. So ultimately the control lies with the ciliary muscles. If they relax, curvature of lens is less. If they contract, curvature of lens is more. If curvature of lens is less, focal length will be more. If focal length is more, you can see far objects. Here opposite, focal length is less and you can see the near objects very much clearly. Right? So you have to write the sentences, that is fine, but I hope you write this summary. Right? I request to draw this diagram and draw this summary. Don't write these points. Just draw this summary, that ciliary muscles, what happens when they relax and what happens when they contract. Fine? Please pause the video and write this summary down in your CW. I hope you have written this. Now we shall erase this. So these are the 2 points which we have written as summary. Ciliary muscles relax, lens becomes thin or curvature decreases, so focal length increases and we can see the distant objects clearly. Vice versa, if ciliary muscles contract, lens becomes thick or curvature increases. If curvature increases, focal length decreases, and we can see the nearby objects clearly. Fine. Let us move ahead. Power of accommodation. Further, it is given that the focal length of the eye lens cannot be decreased below a certain limit. Right? We told that the focal length can increase and focal length can be decreased, but it can be decreased only up to a particular limit. You cannot decrease the focal length below a particular limit. Right? That point is known as the near point of eye. That point is known as near point of eye. Just take an example. Suppose the lens is thin and you are seeing an object over here. Now, as you bring this object closer, suppose now the object is over here. So lens, its curvature will increase. It will become thick. You bring the object yet more near, the lens will become more thick. But there will be a limit. Right? If you bring this object near and near, this lens will become thicker. But up to a certain limit, suppose this is the limit, then what will be the distance between them? 25 centimeters. Beyond this, if you move the object yet near, the lens now will not become thick. That limit is 25 centimeters, and this 25 centimeters is known as near point. It is known as near point. It is also known as least distance of distinct vision. I hope this is clear to you. I will explain this to you once again. Just consider this scenario. This is your lens, right? It is thin and your object is over here. Second condition, you bring your object near, right? So this lens will become thick. You bring your object near, your lens will become more thick, right? Thin, thicker, thickest. The object is coming near. But this distance, if it is now only 25 centimeters, and now if you bring the object ahead, the lens will not become thick. It will remain as it is, because 25 centimeters is the near point of eye, or it is also known as least distance of distinct vision. Beyond this, there will be no change in the focal length. Right? If you keep an object at a distance of less than 25 centimeters from the eye lens, the focal length of this lens will not change. And if you bring object nearer, then you will have strain in your eyes. આંખો પર જોર પડે. તમે ટ્રાય કરજો તમારા ફેસ થી 25 સેન્ટીમીટર્સ દૂર કોઈ ઓબ્જેક્ટ રાખજો, એ બહુ પરફેક્ટ દેખાશે. અને પછી એ ઓબ્જેક્ટને સ્લોલી તમારી આંખોની નજીક તમે લઈ આવો અને એ ઓબ્જેક્ટને જોવાની ટ્રાય કરશો, તમને આંખો દુખશે, તમને માથું દુખશે. રાઈટ? બીકોઝ 25 સેન્ટીમીટર થી જો તમે ડિસ્ટન્સ ઓછો કરો છો તો આઈ લેન્સ પોતાની ફોકલ લેન્થ ચેન્જ કરતું નથી. ફોકલ લેન્થ ચેન્જ નથી કરતું તો કોઈ પણ વસ્તુ જોવામાં આપણને તકલીફ થાય છે. રાઈટ? ઇટ ક્રિએટ્સ સ્ટ્રેન ઓન અવર આઈઝ. રાઈટ? સો ધેટ ઇઝ નિયર પોઈન્ટ. નિયર પોઈન્ટ કેટલો છે? 25 સેન્ટીમીટર. સિમિલરલી દેર ઇઝ અ ફાર પોઈન્ટ ઓલ્સો, કે ભાઈ ઓબ્જેક્ટ કે આઈ લેન્સ છે એનાથી 25 સેન્ટીમીટર્સ દૂર કોઈ ઓબ્જેક્ટ હોય ને તો એ નોર્મલ વિઝન છે, એને જોવામાં કોઈ તકલીફ પડતી નથી. We do not feel any problem in seeing an object which is 25 centimeters away. If it is present over here, then there is problem. There is strain on the eye lens. Now, as there is a near point, there is a far point only. How much far can we see? We can see up to infinity. દૂરનું ગમે તેટલું દૂર હોય એ જોવામાં આપણી આંખોને જરાય તકલીફ પડતી નથી. સ્ટાર્સ કેટલા દૂર છે? સન થી બી દૂર છે. Right? The stars which are in the sky are sometimes far than sun also. જેટલો સન અને અર્થ ની વચ્ચેનો ડિસ્ટન્સ છે એના કરતા વધારે બી સ્ટાર્સ દૂર હોય છે. બટ એ સ્ટાર્સ જોવામાં આંખો ક્યારેય ખેંચાય છે? ક્યારેય તકલીફ પડે છે? નથી પડતી. So our distance till which we can see without any problem, that farthest distance is up to infinity, and that infinity is known as our far point. તો બે વસ્તુ યાદ રાખવાની આપણે આમાંથી, near point of human eye and far point of human eye. Near point is 25 centimeters If the object distance is less than 25 centimeters, then there will be strain on eyes. There will be problem with the eyes. And what is the far point? The far point for human eye is infinity. We can see object at the farthest distance without causing any strain. So there is no problem over here. So this is our range of vision from 25 centimeters till infinity. હવે અમુક લોકોને ડાઉટ થશે sir, if you are saying that the near point is 25 centimeters, then is it possible that suppose here is a lens and here is an object and distance between them is suppose 10 centimeters only, then can we see this object? Yes, we can definitely see this object. એનાથી આપણો vision block નથી થતો. We can definitely see this object, but there will be strain on our eye lens. આપણી આંખોને જોર પડશે, આપણી આંખોને પ્રોબ્લેમ થશે એવો કોઈ ઓબ્જેક્ટ જોવા માટે જેનો ડિસ્ટન્સ આપણા આંખોથી 25 સેન્ટીમીટર કરતા ઓછો છે. જસ્ટ ટ્રાય, તમારાથી 4 થી 5 ફૂટ દૂર કોઈ ઓબ્જેક્ટને રાખો અને એને કન્ટિન્યુઅસલી 5 મિનિટ માટે જોવો, કોઈ જ પ્રોબ્લેમ નહીં થાય. બટ એક પેન લ્યો અને એક્ઝેક્ટ એને તમારા નોઝ ઉપર ટચ કરી દો અને કન્ટિન્યુઅસલી પેનને 5 મિનિટ માટે જોવો, તમારું માથું દુખવા લાગશે. સમજાય છે? બીકોઝ તમારી આંખની લેન્સ હવે એની ફોકલ લેન્થ ચેન્જ કરી શકતી નથી, જેના લીધે તમારી આંખ ઉપર જોર પડશે. આઈ હોપ ધીસ ઇઝ ક્લિયર ટુ યુ. ફાઇન. So this is the power of accommodation of eye. The ability of eye lens to change its focal length to see the near objects as well as the distant objects is known as power of accommodation. Right? See. હવે ciliary muscles relaxed કોને કહેવાય અને contract કોને કહેવાય? Right? See over here. Here the ciliary muscles are relaxed in this example, and in this example the ciliary muscles are contracted. See, these are ciliary muscles. They are relaxed. Here the ciliary muscles are contracted. Now when they are relaxed, the curvature of the lens is less, or I can say the lens is thin. If the lens is thin, the focal length is more, and if focal length is more, I can have distant vision. Here opposite, it is contracted, so it is contracted, so lens is thick, or its curvature is more. If curvature is more, vice versa, the focal length will be less. If focal length is less, then we are using this for closer vision or near vision. Fine, distant vision and close vision. For distance vision, the lens should be thin. For near vision, the lens should be thick. આટલું આપણે યાદ રાખવાનું છે. If I want to see an object which is near and an object which is far, this much things you should remember. If you want to see an object which is near, the focal length should be less. If you want to see a far away object, the focal length should be more. Near object, less focal length. Far object, more focal length. Now focal length is less. What does it mean? That your lens looks like this. Focal length is less. Do you think so? No. If focal length is less, the lens would not look like this. The lens will look like this with more curvature. This is the only problem students have while remembering. Never get confused. The curvature of the curvature of the lens and its focal length are inversely proportional to each other. If focal length is less, your lens will look like this. And if focal length is more, your lens will look like this. So here I can say curvature is more, and here I can say curvature is less. Curvature is more, so I can say the eye lens is thick, and here I can say the eye lens is thin. See why I am explaining this again and again, because this is important for a 1 mark question that is going to be asked from this chapter, and that question will be quite logical. If object is near, lens will be thick. If object is far, lens will be thin. Anything can be asked from this. This is also an important table. We have already seen this, but still if you want to write this, please write. This data is for the objects which are near, and this data is for objects which are far away. Fine. I hope this is clear to you. Sure. Please write this in your CW. Yes, one more point that is given is about cataract. બરાબર, જેને આપણે ગુજરાતીમાં શું કહીએ, મોતિયો. બરાબર ને, આંખની લેન્સમાં પ્રોબ્લેમ આવી જાય, જેને મોતિયો થયો એને બધું આમ ક્લાઉડી દેખાય. બરાબર ને, ઝરમરિયા આવે આંખમાં, બધું પરફેક્ટલી ન દેખાય, બ્લર્ડ દેખાય બધું. What happens? Sometimes the crystalline lens of people at old age becomes milky and cloudy. The lens becomes milky and cloudy, right? This condition is called cataract. This causes partial or complete loss of vision. What happens? Partial or complete loss of vision. અધૂરું અધૂરું દેખાય, બરાબર ન દેખાય, બધું ઝરમરિયા વાળું દેખાય, or બિલકુલ દેખાય જ નહીં. Because the lens becomes milky and cloudy. Lens તો કેવી હોવી જોઈએ? Transparent. The lens should be transparent, but with the age it becomes milky and cloudy, due to which there is partial or complete loss of vision, and such condition is known as cataract. Such condition is known as cataract, and this is easily curable with the help of surgery. A cataract surgery can cure cataract. Fine. Let us see some images. What actually cataract looks like. See, this is normal eye. You can see the eye lens over here, just behind this pupil. And here behind the pupil you can see some milky or cloudy substance. You can easily figure out the difference over here. This is a normal eye, this is eye with cataract. This pupil, behind pupil there is lens which is clear. Here behind pupil there is lens which is cloudy. In normal lens there is a proper image formation over here, but here because transparency is not there, refraction will not be fully done, right? The refraction is not proper, and due to that we do not get a perfect image on retina. We get a blurry image. Sometimes there is partial loss, or sometimes the refraction does not occur at all. At that time there is complete loss of vision. One more image I will show you which shows cataract. You can see the difference between them. This is a normal eye and this is an eye with cataract, right? This is a normal eye and this is an eye with cataract. Fine. So that's all for today, but before ending the video lecture we will write the question and answers, right? Please maintain your CW. Sure. So this is a 1 mark question. This is a 1 mark question. First of all, write this in your CW. What is cataract? For 1 mark or 2 mark. Please write this in your CW. This much, right? Once you finish writing this, you have to write one more question. This: explain the power of accommodation of eye. This can be asked as a 2 mark question, but the paper pattern is of 4 marks, so there can be a sub question of 2 marks also. But please write this, and in this answer there is a small 1 mark question also. What is the near point of eye? 25 centimeter. What is the far point of eye? Infinity. Right, the far point of eye is infinity. So please pause the video and then write this answer down in your CW. So total there would be 3 answers in your CW. The first would be of eye, second would be of cataract, and third would be of power of accommodation, right? So please pause the video and write this much down in your CW. Thank you very much for listening. We will now meet again in the third video lecture and discuss the defects of human vision. Thank you very much. Take very good care of yourself. Goodbye.